Hello everyone. In our control charts videos, many times in our training as well as in some of the other trainings and in some of the other explanation videos, you would have seen a control chart selection tree, something like this, depending upon the data type, what control chart to be used. And today we are going to focus on the attribute chart. And generally, you would have seen if you are dealing with defectives and when your subgroup size is fixed, you will go for a NP chart, and when your subgroup size is not fixed, you will go for a P chart. However, in my trainings, I generally say when your subgroup size is fixed, you have a choice of either using a NP chart or a P chart. This is something which is new and could also be different for you. You would not have heard this statement. So in this video, let's understand what do we really mean by this statement. Let's get into the video. As I was explaining in the introduction, when you are drawing a control chart for defectives, binomial distribution, right? That means if you pick up one item, that item can be declared good, bad, good item, defective item, pass, fail, ticket open, ticket closed. So any data which can be represented in discrete binary form in two forms, then we call that particular data as discrete binary data, and discrete binary data follows binomial distribution. From a quality control perspective, the opportunity for us to get discrete binary data is when we are doing an inspection, and as a result of inspection, we can either declare the entire unit defective or we can declare the entire unit as a good item. That is when we get binary data. So that is why in control charts decision making tree, or which chart to be used, this particular type of chart will be called chart for defectives. But actually it comes from the logic of following a binomial distribution, right? Okay, so when you have defectives and when your subgroup size is fixed, you can use a NP chart. When your subgroup size is not fixed, you can use a P chart. First of all, what is the meaning of that, right? The meaning is when you say subgroup, for example, the definition of my subgroup is every day. Every day, how many samples I am going to inspect? If that number is fixed, that is what we mean by subgroup size fixed. So every day I am going to inspect 500 cases and that number will not change irrespective of my production volume, then we call subgroup size fixed. And if that number is going to change, for example, I produce 5,000 items, that day I inspect 500 items. Another day I produce 6,000 items, that day I will inspect 600 items, then we say subgroup size is not fixed, instead subgroup size is varying. So that is the first part of information that we need to be very clear. Subgroup size fixed, subgroup size varying. And in many of our trainings or many of the previous explanation videos that you would have seen, the decision is made by if your subgroup size is fixed, go for NP chart, and if your subgroup size is varying, go for P chart. That would have been the definition, right? However, in my trainings or where I am explaining control charts to people, I say if your subgroup size is fixed, you have a choice of using NP chart or you have a choice of using P chart. However, when your subgroup size is not fixed, then you can use only P chart. This is how I will train people, and this is where today's video is all about. So what does it mean? When your subgroup size is fixed, can I use NP as well as P? I have a choice of using both. The answer is yes, you have a choice of using both. When to use NP, when to use P? When your subgroup size is fixed, when you have a choice, when to choose between NP and P, that is what we are going to understand. So to start with, I have given a summary table of what a NP chart is all about and what a P chart is all about. Let's quickly get into this, and then I will take you through the Minitab video or Minitab explanation of how to make this chart, and then we will get into the interpretation of the chart. So to start with, let's understand the table of comparison. So what exactly a P chart is and what exactly is a NP chart is. As I told, when you are dealing with fixed subgroups and when you are dealing with the defectives, you have a choice to use a P chart or a NP chart. It's not that always you need to use NP chart. You have a choice to use a P chart as well as a NP chart, because the formula of P chart is designed for both fixed subgroup as well as for the varying subgroup. So how does NP chart work for a varying subgroup? I have posted a separate video. I will share the link of that video in the description. You can look into that video to understand formula for P chart for varying subgroup. However, here we are going to see P chart for fixed subgroup and NP chart, which is always designed for fixed subgroup only. So from a definition perspective, P chart is drawn on proportions, whereas NP chart is drawn on number of non-conformative units, or in other words, number of defective items. That is the definition. And when we define subgroup, we already discussed in detail. In both the cases, the subgroups are fixed. The focus of data are the variable line that we are going to draw. In P chart, it will be on proportion defectives, and in NP chart, it will be count of defectives. And from a formula perspective, the control limits, upper and lower control limits, are calculated considering P bar. P bar plus or minus 3 times of square root of P bar minus 1 minus P divided by N. So this is for P chart. So it's all revolves around P, that is proportion. Whereas in a NP chart, the control limits are calculated based on NP bar. NP bar is nothing but average of number of non-conforming units. So that is called NP bar. NP bar plus or minus 3 times of square root of NP bar multiplied by 1 minus P bar. Again, how this formula works in Excel, I have made a separate video, NP chart video. I will share the link of that video in the description. So for the detailed understanding of the formula in Excel, you can look into that video. This video is more to give a comparative view of both these charts. And as we are explaining now, we will get into when to use and the practical exercises, right? So when to use, when we want to compare performance across non-standard subgroups. When we say non-standard, that means non-standard in the sense, what we mean is, let's say there are two different shifts operating, and as a plant manager I want to compare both the shifts, right? Or if I want to have a macro picture, when I say macro picture, what do I mean by macro picture? I want to understand about the larger picture, not about the one particular instant or one particular subgroup analysis that we have done. From on those instances, we will be understanding using a P chart. When I want to understand something which is very close to my shop floor, that means how many units failed today, is something easy for a shop floor person to understand rather than understanding the proportion of units that got failed. So for somebody who is more concerned about a scope which is limited, and for him to understand what exactly happened on that limited scope, then the tool or the chart that we can use is NP chart. So this is how we can understand about P and NP chart. Both charts can be used, but depending upon where you are going to display, who is going to look at it, and what kind of inference they want to make, the charts are differ. So let's now get into Minitab and understand how does these two charts work in Minitab. I have taken an example where we are comparing the or we are going to plot the data in a bulb manufacturing company. In a LED bulb manufacturing company, every day the number of bulbs that get inspected is 500 units. Irrespective of production volume, they will inspect 500 units. So based on the fixed sample size for every day, here the definition of subgroup is every day. Based on the fixed sample size for the subgroup, we are identifying the number of defective bulbs, and for that we are going to plot the chart. So if I click on stats, if I click on control charts, and I go to attribute charts, and in attribute charts I go to P chart, I can select the defective bulbs, and then I can select the number of bulbs. I can go to P chart options, I can put a tick mark on all the 4 tests here. So then I click OK, I get a chart. And what is this chart? This chart is a P chart, proportion chart. If I double click and open this proportion chart, you will understand your Y axis is drawn on proportion and X axis is drawn on the time series, the order in which the data is collected. Now let me minimize it and let me also draw you a NP chart. So I click on stats, I go to control charts, and here I click on attribute charts. I select NP chart, and in NP chart again defectives is my variable data, number of bulbs is my subgroup size, and now I go to NP charts and I go to test. I can put a tick mark on all these tests. So these are the 4 tests we need to do for a attribute chart. So I put a tick mark on all these tests, and then I click OK, and then I click OK. So what happened? I get my NP chart and a P chart. For a better understanding, I have copied both these charts to my PowerPoint presentation to put them next to each other and study both the charts next to each other. I have taken it to my PowerPoint presentation. Let's get into our PowerPoint presentation. So in this PowerPoint presentation, first let's look at the P chart. If you see this P chart, right, as somebody in the shop floor, what do you mean by P bar being 0.013? It will be difficult for me to understand. So what we are saying is, out of the total number of units produced, roughly 13% is your average defective rate. That is the meaning, but it's very difficult for me to understand. If I am a shop floor machine operator, understanding this becomes difficult for me. However, if I'm a plant manager, This information is more important than number of defectives, because if I now show you the NP chart, if you see the NP chart, your average number of defective is 6.92. Average number of defective is 6.92. What is 6.92? On what subgroup size the 6.92 get calculated? That information generally don't get displayed on a NP chart. If you see an NP chart, how many units was inspected, on that your 6.92 is your average number of defectives. That information is not available in the chart. In fact, I generally used to suggest to people when I'm doing consulting and when I do a Gemba walk, when I see a NP chart, I suggest people to also give an information what is your fixed subgroup size for which this NP chart is drawn. Somewhere you need to write it. If you write 500, then I will be able to relate to the 6.92 with respect to 500, right? Otherwise, the 6.92 generally cannot give me a true sense of what is happening in the shop floor. Whereas for a plant manager, 0.013 proportion will give a picture of what is happening in the plant, but this 6.92 will not give an idea. Whereas when you think about somebody who is near the machine, operating the machine, he is only aware, or he is concerned about what is happening in his shop floor. He is not concerned about the overall plant or what is happening across multiple lines. He is more interested about his particular mission, his scope. Then he knows, hey, every day I produce certain number of units, but my line inspector will inspect 500. So if I get 6.92, that means 6.92 average defective items per 500 units that get inspected by my line inspector. This information can be understood and it can be easy for the shop floor machine operator or operations supervisor in the shop floor to understand better. Whereas the 6.92 does not make sense for the plant manager. Similarly, this proportion, average proportion of 0.013 will be very difficult for a machine operator or a floor supervisor to understand, but he understands average non-conformity or average number of defective items 6.92 much better than proportion. So the choice of should I use a P chart or should I use a NP chart actually stays with who is the recipient, where is this chart getting displayed, who is going to look at it, and by looking at it, what kind of decisions they are going to make. So if I want to summarize it in a very simple way, if the purpose is to have a micro analysis using the control chart, I suggest to use a NP chart. Whereas if the purpose is to do a macro analysis, to understand a larger picture, what is happening in the plant, what is happening across multiple shifts, if that is something that we need to understand, then a proportion chart would be a much better chart. So to summarize, friends, the usage, when to use a P chart, when to use a NP chart, if I want to summarize it for you, P chart, if you need a standardized way to compare defect rates across different groups or time periods, even with fixed subgroup size, you can definitely use P chart. Don't assume P chart is designed only for varying subgroup sizes. P chart can also be used for fixed subgroup sizes. And P chart is ideal when the proportion provides more meaningful insight than the absolute count. That is when you use a P chart. Whereas when you come to NP chart is used when subgroup sizes are fixed and stakeholders are more comfortable interpreting the actual count rather than the proportion. So people who are consuming this chart, people who are looking at this chart and making decision, if they understand the actual number much better than proportion, then NP chart is the right chart to be used. Easier for on-floor operators to monitor and react to specific number of defects which they are more familiar about. They know the number of units they produce, they know the number of units that get inspected. So from that perspective, they also find comfortable to understand the average number of non-conforming items against the number of units that got inspected and against the number of units that got produced. So knowing these two information makes NP chart becomes easy for them to analyze and understand what is happening in the shop floor. So as a last takeaway point, the key decision making factor of should I use a P chart or should I use a NP chart is if the audience or the purpose is to understand the rate or proportion or percentage, whichever way you want to call it. If the purpose is to understand the proportions, then we can go for a P chart, which gives you a macro picture, larger picture. But if the focus is on the absolute numbers, more practical, more close to the place where the action happens for people operating machine, shop floor supervisor, then the chart that you can use should be NP chart. Friends, I hope this particular video gave you some clarity on when to use P chart and when to use NP chart. Thanks for your time. So more videos on control charts, quality management videos and Minitab tools and techniques, I request you to kindly subscribe our channel and support our channel. Thank you for your time.